Hello people, welcome back to my channel. So hope you are enjoying the Python skill series so far. We have covered different topics in Python skill series, and so far we have come in object oriented programming. So in Python, the concept of OOPS, that is the object oriented programming, is very important whenever you want to build any web applications, or whenever you want to deal with the memory management or internals of the Python heap and stack. So that comes under the memory management section. So there essentially you want to understand the concept of classes and objects. This same thing is there in Java. So the same thing is also there in Python. So that's why Python has got the flexibility of object oriented programming language. So today let's understand what is the concept of static memory and instance memory. So before understanding what is static memory, let's first understand what is instance memory. So we all know how to define a class and how to define function. So I have this first example. So this is regarding the instance memory. So in instance memory, what I'm doing is I'm creating a class that is parent, and I have another class that is child, which inherits the parent class. So child is the base class and parent is the parent class. So I'll just try to draw some diagrams here. So this is my parent class and this is my child class. So let me label this as parent, and this is child. Okay, so inside this you have the very first method that you can see. Just only look at this highlighted portion. So this first line you can see, that is a method. So this is a method definition and you are writing something like this. So these are two underscores. So it is written with the help of two underscore, like in it you write like this. So init is a special reserved function which is there in Python. Now it takes this one argument, that is self, which refers to the corresponding class. So self refers to the parent class. So say here we have a variable that is self, which is solely to the parent, and similarly to the child class we have self. So what this essentially says is, like, it is basically used for initialization of any of the variables. So now any of the variables which are contained in this class are referenced as self.a, and it is assigned a value 10, and self.b, it is assigned a value 20. So this particular function, so what is the functionality, or like why do we write the init function? Basically to you initialize the variables. So these are the instance member variables which you can say. So as and when the class gets created, parent class will have two variables. So you have a is equal to 10 and b is equal to 20. So this is the status of parent class, and then inside a parent I have a normal function which is bar, and inside that I am also passing the same variable, that is self, and inside that I have a statement self.c is equal to 30, like here. So the speciality of this particular method is, like, whenever the function call goes to this particular parent class, it will have these two variables in its memory. So that's what I have drawn here. So this is the story of the parent class. Now you have a child class which inherits the parent class. So inside the parenthesis I am passing the reference of parent class. Now Here also we have to do the initialization of the class. So whenever you have a class and if you want to do the initialization, you basically write this init function and you pass that self. So self corresponds to this child class, like I have drawn here. So each of the class will have a self variable corresponding to the initialization for its further variables which are there down the line of code. And after that, what you can see is a statement that is a function called to super. So super is nothing but to the class which it referencing above. So if a child class is calling a super method, that means it is calling to its parent class. So this is the impact of the keyword or the method super. So function call will go to this class and it will do the initialization. So super dot init function, so it will basically activate this particular class. Then inside the child class, I again have a function that is foo, and inside that I pass the parameter that is self, which is this one, and I'm just printing the variable, so self.b. So now what I'm doing is I want to access these variables and I want to see which function call is happening and so on. So what I do is now I have basic two classes, one parent class and one child class. I want to basically do the instantiation of the object. So in uh, Java, if you know, we used to create objects of the class by using the keyword new. Here we don't have any such concepts, just by simply writing this. So whatever the child class is there, we basically do a constructor call. So this init function can also be called as a constructor to the class which it belongs. And as soon as the compiler sees this line, so an object of the child class will be created. Now here, mind you, we are creating object of the child class and not the parent class. So obj, if I draw here, that is obj is an object which resides inside the child class or which is instantiated or created by the child class. Now obj is calling a foo method. So first, whenever this line is executed, compiler will go to the child class or from which class this particular method or function call is done. So it will go to child class, it will do the initialization with the help of this thing. Why? Because it has to create all the instance variable member variables of this class. So it will check whether foo method presents inside this class or not. If it is present, it will execute this statement and it will print this thing, that is self.b, but b is not there inside this class. So value of variable b is not inside this, it has to be referenced from somewhere else. So it will check whether any initialization or any value of b is present inside this class. If it's not present, it will go to this statement. So the control will now go here and it will call the parent class and it will say the value of b is 20. So if this much is clear, I'll just run this line of code and let's see, we are getting the value 20. So it is as simple as that as per our explanation. Now what I do is I want to call one more function, that is bar function, but mind you, bar function is residing inside the parent class and the object is of child class. So first and foremost question is that whether will this get executed. My answer is yes, it will get executed. So first, till this part it is the same, so it will print 20. Now what happens is uh, the object is of child class and the function call which is doing is of the parent class. So when this line gets executed, it will see whether the object which is instantiated by the child class, does that particular class have the method bar, it sees that it does not have any method called as bar, the function call will go above to the parent class, and it will basically fetch this 30 and it will print in the console. It is as simple as that. So let's run this. Okay, so I just have to, yeah, just this print. Okay, 20 and 30. So it is printing this line and it is printing this line. So it is as simple as that. Now what are these two classes has is a parent class has variable 10, 20 and 30. So 10, 20 and 30, and this has variable 20. Now I want to see how many variables are present inside the object, or instance member variables are present inside the object class. So in order to check that, I have this thing. So whenever you want to print like how many variables are contained in any particular class, you basically write this. So object dot variable name, that is you after the class creation, whatever variable you have instantiated, you basically call a dictionary. So it will basically return a dictionary of values, whatever it has. So if I just run this again, so you have A10, B20 and C30, that is key value pairs. ABC are strings and 10, 20, 30 are integers. So that is in reference to whatever we have discussed so far. So it is simple if we don't do a function called to bar, and again if we do this print this particular statement. So obviously the function call will not go to bar and C will not get uh, instantiated, or it will not be created by this thing. Instead it will print only 10 and 20. Let's see whether that happens. Yes, it is correct. So the control basically will not go to bar and it will only print 10 and 20. Why? Because uh, self.c is present inside bar method. It can only be created once you do a function call. Okay, so what if we just comment foo, and now if we just call only bar. If we call only bar, because bar resides inside the parent class, so everything will be created. So if we just run this, we can see A10, B20 and C30. So regardless of what the child class is, the function call is from the parent class, everything inside that will be created. So it is as simple as that. Now one more way of object call is like you can do something like this: obj dot d is equal to 40. Now inside this you can see you have 10, 20 and 30. You don't have 40, but with this particular line what happens is it will create one more variable on the fly, 40, and it will reside inside this parent class. So if we just run this particular line, you can have A10, B20, C30 and D40. So now if you might ask like what if I comment this particular bar, okay, and if I just try to access this, that is self.c, ideally it should work, right? Because this particular function we are not instantiating and we are calling self.c. So if this particular, so with self.b is okay because it is referencing to the upper class, and self.c it's also referring to the upper class, and so it should print ideally, right? So let's check once again. No, it will not print because child object has no attribute c. Just remember, when we called self.b, it was outside this particular any function. So it was not bounded. These two variables are not bounded to any function, but when you called self.c, that resides inside a function. So unless and until you do the function call, you cannot access that variable. So you have to take the permission of this class, or you have to call that function, and then you have to access that, else it will not get printed. So that is the basic story with instance memory in Python. Now if you understood this thing, we have a similar thing that is called as static memory. So I'll just comment this out. Okay, else it will just run twice. So we have now something called as static memory. So static memory, as the name suggests, is used to initialize the static variables. So we again have the same class parent, and inside this we have a static variable. So these are called as static variable. X is equal to 11, and then we have the again same function self dot a is equal to 20. This here is called as static member, and this is called as instance member. So these are the two differences among these two variables, because this we are calling after the function call. These are this we call before the initialization of this particular function. Again we have a child which refers to the parent class, and inside that we have super method which is referencing to the above class. And here what we see, that is a decorator, means this particular foo function, now it is being decorated. How it is decorated as a static method. So inside that we are printing child.x, and then we are doing a function call. So ideally whenever this particular line gets executed, so here what happens is you don't need to do initialization. So you don't need to create any objects as you see in instance variable. So only in instance variable you create the object, but in static variable you can directly access that. So whenever this particular line is executed by the compiler, child.foo method is called by this, and child.x, which is a static method, it will basically return this variable, that is x is equal to 11. Let's go ahead and execute this. Okay, so okay, 11, we are getting the answer, that is 11. So it is as simple as that. So just these two things are important when it comes to memory management. So uh, in the future we'll be doing some of the other activities relating to memory management and heap memory and stack memory. So there this becomes handy. So well, that was all regarding static memory and instance memory management in Python. So hope you guys enjoyed this video. We found you got educated about this video. Please do like, share, comment, and if you're new to this channel, please consider subscribing. Thank you very much for watching this video.